Hi everybody, it's crazy. It's Monday and it's time for the UPBGE video of the week. Now before I get started, gotta give a shout out to my trusted because you guys rock. To my crazy fam, I love you guys. Now we're up to episode number 98. Now we're almost to the 100 mark, and last week we ended chapter 5. This week we start chapter 6, which is physics. We're going to be starting a new file. And I'm using 0.2.5b. I use 0.2.0 for my projects. I really don't want to get files messed up, so I'm using 0.2.5b. I heard there was a 0.2.6, but I think that's a little bit of a side project. One person, Fred, on my channel was telling me that it works pretty well for a lot of the projects he's working on. I downloaded it. I have not tried it, so I cannot say yay or nay. But if you'd like to learn more about it, just drop onto the UPBGE server and ask them fellas out about it, and I'm pretty sure they'll tell you. All right, and if you're not on the UPBGE server, the link is down in the description. Also, my server is down in the link description. The UPBGE server website is also in the description, and a lot more other stuff is in the description, so take a look. All right, so let's get started. Chapter 6, Physics. Welcome to Physics 101. We are going to be your professors for this chapter. Follow along as we dive into a dynamic world of falling apples, run alongside bouncing balls, and soar with flying spaghetti. Alright, so what is physics? In the real world, the laws of physics govern everything from the smallest subatomic particle to the largest galaxy far, far away. Luckily for us, we don't have to understand quantum mechanics, Newtonian physics, or Euclidean space in order to make a fun game. A physics engine handles game events such as collision detection between objects, moves objects in a physically realistic way, and even deforms objects as if they were made up of a soft material. A physics engine moves things based on a set of predefined rules so that you, the artist, don't have to manually animate every object interaction. Compared to traditional keyframe animations, which are pre-made, the dynamic nature of the physics engine means that it is inherently non-deterministic. The motion of the object depends on the physical property of the object and its state in the physical world. This unique property makes games that utilize real-time physics fun to play around with, if not unpredictable sometimes. As usual, this chapter comes with a collection of example files that showcase what the physics engine can do. You can find them in the folder Chapter 6 Demos. So if you come over here and we can go, we go down here to Chapter 6 and you go into Demos. You got all these cute little blends you can play with, figure them out, bullet house, constraints, constraint chain, constraint trampoline, constraint watermill, and physics types blends. Okay, these are all ones you can play with to get a little bit more familiar with physics. Okay, overview. Because physics is such an integral part of the Blender game engine and BGE, physics-related settings are found in many different places. However, scattered they might look at first glance, there is a pattern to this chaos. The physics settings can be broken down into these sections. World settings. Okay, so let's exit out of this. Okay, so you got physics in your world setting. Okay, there's things that happen. Contain settings that affect the entire scene. Global settings such as gravity strength can be found here. Okay, so that's talking right here, right in this area. Right now I ain't got nothing in there, so it doesn't really have anything, but your environmental lighting, your mist, it's all there. But in physics, you also have your others. Where are they at? There's more to it than just that. Okay, right now, it's just, these are the main ones that we use. Okay, so world settings. Figure 6.2 shows the world properties editor. Okay, so that was this one right here. Now it's going to look different than what it does in the book because we're using UPBGE. There's some settings that just got loopholed out and don't even be used anymore. But you've got your horizon color, your mist, you've got, and it says physics, but the physics isn't here. If you look down, there is no physics because they're already set. Okay, the physics, it's, you mainly use bullet physics in a BGE. They're talking about going Vulcan, so that may change. You could change your gravity. Let me switch over here so you can see what I'm talking about. Okay, you got bullet physics, that's the engine type. Okay, and actually, you know what? Where's it at? I'll go ahead and bring that up. Give me a second. Did click on it, takes a minute. But you got bullet settings and your gravity, which is 9.8. And you got other different physics steps like max 5, sub steps, FPS is 60, max is that. Okay, so back over here. Okay, this is regular Blender. Let me go into the game engine so you can see how it looks. Here it is, and if you notice in the game engine, there's none there, right? Okay. None in here. I don't see no physics in here either, do we? Isn't that interesting? Okay, now Blender Render. Does it have it in that render? No. Okay. Well, makes a fibber out of me. I think most of your physics gets done over here, but I don't know why it's not in the world tab. Oh, okay. You have to go here, which is the scene. So they did change that. So let's go over to the scene here. Ah, there we go. Okay, so your engine is bullet. Okay, same thing with across the way. Physics solver is sequential. Gravity 9.8. You've got physical steps 5, substeps, so on and so forth. Everything that was just in there. Okay, as you go through. And you got all the way up to obstacle simulation, navigation mesh, level of detail, so on and so forth. But this all has to do with the scene. So from the original time, it used to be over in here, but they had moved it to here, okay, to your scene, okay? All right, and that's both Blender Game Engine and, okay, that's 2.79, and 0.2.5, which is based off of 2.79.7. Okay, so those are all that was the latest one up until 2.8. Okay, objects physics settings, which is this one right here, if I do believe, yep. Okay, but you won't find that here because that isn't actual physics. It's here. Okay, and as you go through it, you can make it static, no collision, static, dynamic, rigid, so on and so forth. Okay, there's many things. Then you got the material physics settings. Let me click out of that for a second. Oops, I didn't want to click on Ghost. The material panel is not only a place where all the... Did I even read that? Oh, no, I did not. I'm sorry. Okay, so in the object physics, which is this right here, any game engine object, mesh, lamp, camera, empty, and text can be turned into a physics object. Once physics is enabled for an object, it starts obeying the rules of the physics engine, transforming the object from a static object into something that falls, collides, tumbles, and deforms. Okay, and of course they have this, the physics engine, so you can see it as well. Okay. All right. Now the material physics. The material panel is not only a place where all the graphics magic happens, it also contains additional physics that control how the surface of the object behaves. Let me see, that should be here. And I believe you have physics down here. I don't know if it's in this. It's under game settings. Yep. Okay, so UPBGE just took out the word physics and they combined the game settings with the physics engine, because you can enable physics, you can basically as long as you enable physics you should be good, because most of it is controlled through here. Okay, so I'm going to go ahead and finish reading that. Settings such as surface friction can be found here because an object can have multiple materials. Material physics settings allow the artist to assign different surface materials for different parts of a single object. Okay. Let's see. Yeah, so I did all that, right? Yep. And a lot of the options have changed from Blender game engine from before to now to UPBGE, so kind of watch that, but a lot of it's still the same as long as you're looking around for it. If you enable physics here, then you can the material can have physics done here as well. Okay, object constraints, which is this little guy right here. Okay, when you were young, your parents probably set out certain rules that you needed to abide by. If any of the rules were broken, bad things happened. Physics constraints work in roughly the same way, without all the drama and door slamming. They allow you to set up simple rules that the objects follow. Rules such as tracking one object to another or limiting their range of motion. With constraints, it's possible to realistically represent many of the structures that have a limited degree of motion, such as hinges, wheels, and chains. Okay, so we got all these we can choose from. Okay, camera solver, follow track, object solver, copy location, rotation, scale, and transforms, limit distance, location, rotation, and scale, maintain volume. There's so many to choose from, and if you're going to be doing character creation, you're going to be looking at a lot of these that you will use in order to make it to where the elbows don't bend backwards, or the head only moves in certain directions and doesn't turn all the way around. Okay, that's what these constraints do. They actually limit and make things worse. Inverse schematics, those right there are what you would use for rigging. You can have something be a child of something. You can have it follow a path. You can have it pivot on a certain point. A lot of these things you can use. You can track to stuff. You can have the camera track to a certain area on your map in part of a cutscene, or have it to where that cube tracks to the player and it chases the player everywhere. There's many things you can do with that. Okay. Physics sensors and actuators. Let's see, where's that? Okay, that's down in here. Okay, that's going to be down in here. Okay, physics sensors and actuators. Except for maybe the case of the Rube Goldberg machine, where everything happens in a predetermined manner, most games would be pretty boring if there were no way to make an object move at a user's command, or to trigger a reaction when two objects collide. Actuators and sensors fulfill these two roles, respectively. Actuators are part of the logic brick that carries out an action, such as applying a force to the object to make it move. Okay, so that's these guys right here. These right here are your end result. This is what they do. They will be either visible or non-visible. They'll either vibrate or not vibrate. They'll either change states or not change states. They'll have sound or not have sound, or steering, so on and so forth. There's so many you can play with here for your actuators. Okay. Sensors, okay, that's these guys right here, okay, are triggers that detect when something happens in the game, such as when two objects touch. A combination of sensors and actuators makes a game truly interactive. By giving the game engine the ability to make decisions, So when you set an always, it will always happen. Okay? If you set up a collision sensor. It says, okay, when the cube hits the ground, what is it going to do? So when you say you put that collision on there and you have your property and it's ground, see, create a game property, you're going to call it ground. Okay. Doesn't matter what it is right now because we don't care. Okay, and when you say ground, so when a cube collides with the ground, because I've got it set for cube, okay, when it collides with the ground, it's going to do something, okay? And you can have it move as soon as it touches the ground. So if I hit it, you know, make it to where it goes on the y-axis, okay, when it touches the ground, gravity makes it hit the ground, it's going to take off in the y direction, okay? So, I mean, that's just one of the things you can do with these, with the collisions and stuff. Those right there actually are all neat things, okay? Alright, so Python. Okay, here goes that scary word again for some of you people. Me too, I mean, sometimes I get, you know, I get a little sideways with Python. But once you start learning it and you get a good handle of it, it's not too bad, okay? So Python, in addition to all the physics settings one can access from the graphic user interface, an extensive Python API is at your disposal. The Python API gives you programmable control over many aspects of the physics engine. With Python, you can dynamically set many of the physics options while the game is running. It even allows you to accomplish a few things that are not possible from the graphic interface. For instance, Python can be used to create realistic vehicle physics. Okay, and I'm going to switch over to here real quick. There we go. Okay, Python can be used to create realistic vehicle graphics. Okay, it shows the text editor with the Python script open. Okay, so this is a small little Python script for a vehicle, and that's the suspension is what it's showing. Okay, so now that you have an overview of what physics is all about and where to find all the settings, the rest of the chapter will explain how to use these settings in combination to achieve various effects. Okay, and we're up past our time. So next week what we'll do is we'll start world properties. We'll do world properties, which is page 9. Okay, so page 9, chapter 6, world properties, next week. Until then, we'll see you then.